I am Chandrashekhar Singh, and today we will be talking about journey of Presto-on-Spark on Velox stack at Meta. So in this talk, we will be talking about Presto-on-Spark, its use cases, where it fits in the wider Meta batch ecosystem, and some of the important features we use, and dive into the motivation on why we have been working on the Velox integration, where we stand in our journey. And finally, I will be ending the note with some of the numbers from production and how it has been changing the landscape of running the batch workload at a scale. So, where does it fit? So, in a nutshell, Presto-on-Spark in general steps in where a query simply becomes too big for our typical regular Presto deployment. For example, they start hitting into local memory limit at the worker level, or the distributed distributed cluster-wide limit, or they just need access to thousands of executors in order to finish in a reasonable time. Or basically this query has simply too many stages, which is a risk when you are running on a regular cluster, because query is going to fail or start impacting other queries running on that cluster. Another class of workload is long-running queries. They are more prone to the failures because your worker nodes can go out of the cluster for maintenance or other events, or they can simply fail. And because there is no fault tolerance in the Presto stack, it basically means you lose on the progress and the compute, as well as it delays the completion time. So this is pretty expensive, specifically for the long-running queries. So in Meta, if we have to look at it, any queries which is basically more than 3 hours in duration, the usual home for those kind of queries is Presto-on-Spark. We do have smaller running queries as well, but that typically falls into the earlier categories that I talked about. So at a high level, it is a Presto cluster running with Spark runtime. So Presto and Spark is basically where you have the runtime benefits of the Spark, but for parsing optimization planner or for the evaluation specifically, eval layer, you have the Presto code. So it's a custom Spark app which runs on a Spark cluster. So in the Spark driver, you'll see that we have all the Presto bits, and basically once we have the final fragmented Presto fragmented plan, we create a DAG of RDDs, and from that we hand it over to Spark's scheduler to take it for the runtime. And from there, Spark scheduler takes care of all the resource allocation, task scheduling, retries, task level or stage level, and so on. And once a task lands on the executor, as part of task execution, same Presto eval is used to used to run the fragmented plan and return back the results, or write it to the persisted shuffle. So some of the notable features that basically makes this stack reliable and the addition in the Presto is task and stage level retries that basically comes from Spark. In addition to that, we have built smarter retries, and these are part of the Presto code base and part of the custom Spark app that runs on Spark runtime. So for example, when you have the broadcast table becoming too big, and when it is possible, we can enable partition join. That automatically kicks in, or basically run with higher hash partition count, so that the amount of data you process at each node becomes smaller. Similarly, containers with increased memory is another thing which basically throws in jumbo container, we call it, which are like massive containers, so that the task can go to completion. In some cases, it's not simply possible to disable the broadcast, because you need broadcast to do some of the joins. Next is we built the AQE framework in Presto similar to Spark, because since this is a custom app, Spark AQE doesn't fit in here. The framework is there. We implemented join swapping, which does the runtime join swapping based on the intermediate stages stats. For broadcast, we use file-based broadcast because it allows us to do multi GB broadcast rather than being limited by few hundred MB, which is more realistic if you are uh, collecting the data back on driver and trying to broadcast it over workers. Then HBO is another standard feature which pretty heavily used. And then on top of the stack, we have dynamic routing of queries. This is one of the pretty critical features, as well as from user perspective, it's basically what? When a query grows bigger, how do you know? You don't know. You basically want that when a query grows bigger, it fails, it runs into memory issue and so on, that query automatically gets routed to Presto-on-Spark. For a user, it's basically the query has been running and it's going to continue to run, and they will keep getting the result back. But this seamless movement of query, I mean, the whole reason Presto-on-Spark exists, rather than user being prompted to rewrite their production running queries suddenly one night when it is too big to fit in Presto, that's the use case. And dynamic routing of queries actually helps there. Moving on, let's talk about motivation and Velox integration. I mean, on motivation, well, it's Velox. So, I mean, last 2 days we spent talking about why and how Velox has been helping. So, when we are running batch pipelines at our scale, and Ankur also briefly talked about it, the efficiency gains translate into massive infrastructure cost. The reliability pays into some of the critical pipelines where you have the monetization pipelines or AIML pipelines basically completing on time. This is very important. So Velox integration, I mean, we have seen with Prestissimo that there has been more than 2x efficiency, 4 to 6x latency wins, and on the that's the efficiency angle. On the reliability front, we all have faced long GC pauses, worker ohms, and pretty loose memory accounting with Presto Java stack. With Velox memory management and faster execution time, we have seen dramatic reduction in the query failure rate, which were the numbers I will be going with in later slides. Coming to maintenance and operations, if we look at it as part of the Presto batch ecosystem, it's pretty involved, hard, cost consuming in terms of infra and people to run 2 stacks, basically maintain a Java eval stack as well as C++, keep the feature sets similar, which is quickly diverging, as well as basically certifying every releases every week and making it to production. And in production, you try to reason through, oh, if there is a query showing different output, is it because the regex behavior is different, and so on. And it breaks the seamless movement of queries between Presto and Spark and Presto, which was the whole premise why Presto and Spark was created. So uh, uh, another thing is this overhead just not stands with the Presto team. It spills over to other team, where other teams like storage, IO, Metastore, they have to maintain and support client APIs for Java. So that's the whole motivation front. At a high level, everything remains same. Uh, Bigger blocks. One thing that changes that once a plant fragment lands on the Spark executor, the on the JVM side, we spin up a sidecar if it's not already started on that executor, and over HTTP we communicate with that and we send the plant fragment. The plant fragment is translated into Velox plan, and then all the heavy lifting is done in native worker. So if you look at it, native worker directly talks to Hive storage to read and write the tables, shuffle service, which is our Costco, uh, to read and write shuffle data, and distributed file system, which is used for spilling as well as writing the broadcast files. The communication between JVM and native worker on the executor side, this is over HTTP, and Mo- uh, it's all metadata and stats which are mostly flowing, getting transmitted over the wire. So not over the wire, on the same host. So there is no data exchange there. So it keeps it lightweight and more reliable on that front. So, some of the notable additions or what it took to make it possible. We rebuilt file-based broadcast for native worker because the worker is now Velox, so we we had to rebuild it in the native stack, where basically the native workers directly write to the read and write to the file system for the tables which are required for the broadcast. The shuffle integration was another piece which we had to do. This simply meant that we adding new operators for these new integration points, as well as making sure that those operators have the plan translation from Presto's physical plan to Velox plan. Uh, Given that native workers as well as Velox comes with a bunch of additional configs and so on, we had to build a framework to do the wiring for the config for all the way from our config store to drivers and all the way going to the native workers. One important addition was shorted shuffle and short merge join, which was built for sequence storage use case. That's something we didn't have in Sapphire Java, and this has been unblocking a lot of new use cases on the stack. And the memory manager management integration for the new operators or wherever have been missing to make the stack more reliable. So going into part two production, what it took to take new stack to production. So correctness has been our P0. One thing we basically focused on, and initially, last August, we decided that we need to have a zero correctness issue for a sustained period of time before we can take this stack to production. Once you have the correctness sorted out, you can always pick and choose which queries to promote to production. You can always go and say, you know what, I'm seeing 40% of the queries which are showing 3x gain, and those are the ones we are going to promote. And basically, you are like, okay, there is not going to be any correctness issues. So, and then in parallel, we focused on the improvement, missing features or regression. Given Prestissimo has been already running like more than 90% of production workload at that point of time, our expectation was there should not be major correctness issue, and specifically given that it's the queries have been moving between these two systems. So we took the approach to replay and verify all the production queries continuously every day. The biggest challenge was, okay, how do we make sure at this scale we can replay the query? It's simply not feasible to have additional infra which is continuously replaying production query. So we started with deduplication of query shape. So basically, let's say if I have a daily pipeline, you pick only one instance of it rather than running all the 24 hourly runs. Or if you have queries where basically the queries are in a form where it's just different buckets, bucket of the table the queries are running into. You just pick up one randomly and run it. Another thing we did is take the random sample of 20% of the queries and have a goal of certifying all the production workload in last 5 days. So, and then on every day, basically tries it, fix the performance issue, reliability, and sort out the correctness signals. So, correctness has been slightly, sorry, correctness has been slightly noisy due to non-deterministic queries and due to non-differences. So we had to improve verifier and verifier as well as some of the validation framework. So one of the things that was crucial and specifically came from Prestissimo being the golden copy and becoming the production standard is we verify the query, but when the verification completes, for the mismatches, correctness mismatches, we replay the query on Prestissimo whenever possible, like whenever the scale doesn't cause it to crash or fail. And then Prestissimo, in the second run, Prestissimo acted as the control or baseline, and that minimized the noise to really large extent. And at that point, it became pretty feasible to end up with just a handful of queries which you need to manually resolve. I mean, we didn't really see many correctness bugs. There were two, and one of the things which kind of threw us off, because these were impacting very small percentage of queries which so one category of queries were metallic tables. This was the instance where some of the tables which had the mutations, we were seeing different row counts. And ultimately, you start with the premise, oh, there are differences and there are JSON extractor differences and so on, specifically when they are used in the join. And then when you end up with the row count differences, you have to, is it real or is it because there are non-differences in some of the functions as well as UDFs, and since they are used in join, it makes it. I mean, in both the that was the with the metallic tables, and another was on the legacy behavior. We hadn't turned it on. So in both of the cases, the thing was the config wiring was missing, and a config was not specifying enabling these features, and thus caused it. After that, basically, we replayed the queries for almost 3 months, doing all the performance improvement as well as feature addition before taking it to production. So we had the daily release to detect and fix issues early. So if we talk about first couple of months, we had the nightly build, and we went through multiple validations, basically production sample queries, query banks, and so on, before we certify a package for replay, not for pushing out to production, but replay. Because if a bad package releases to replay, we lose 1 day of signal. So that's a pretty good hit on the amount of compute available for other queries. So and then it goes for replay, and yes, we replay 20% of the queries, and we have the result to basically further refine and fix issues. Uh, there was another thing. We have continuous other system being released as well. We have Spark being released, we have other wrappers being released, and so on. So how do we make sure that other releases don't have new features or changes which are gonna break Presto-on-Spark on Velox, because this is still not in production. So we added validation node in all the upstream projects in their release cycle, so that even though this thing is not in production, if it's broken, it quickly shows up there. And then typical phase releases to contain blast radius. So where do we extend now? So we have more than 40% of the queries running on Sapphire Velox. One thing to clarify, Sapphire Velox and Presto-on-Spark Velox, I've been using interchangeably. Sapphire is the internal name for Presto-on-Spark. So we have been running more than 40% queries on Sapphire Velox since last November. And we have been seeing 1.6x efficiency, compute efficiency, and 1.2x latency improvement. In terms of reliability, our success rate went from 97% to 99%, and we have moved from Spark 2 to Spark 3 for this workload. As the next step, we have identified and actively working on resource efficiency and shuffle area in order to reach 2x efficiency. We plan to deprecate Java Stack in coming months once we have 100% of Presto-on-Spark queries running with Velox. Some of the learnings. Yeah, initially we didn't have daily stable builds, and continuous query replays also took some time to set up, but the churn it caused within the dev team was significant. So this really pays off if you have continuous feedback cycle for this. Uh, Maintaining multiple uh, stacks gets tricky. So when we started, we were trying to Veloxify Presto-on-Spark. At the same time, we had Spark 2 to Spark 3 upgrade happening. So if you think about it, we had 4 stacks in parallel: Presto-on-Spark plus Java, Spark 2 running in production. On Spark 3, the next thing we want to do, Velox on Spark 2, because we know we are trying to build Veloxify the production version, and then another version on Spark 3 because we want to make sure that these projects don't delay each other. One thing we learned that major focus, keeping the focus to 1 to 2 variants and basically treating the other variants as incremental, it helped us a lot. So initially we started with let's do Spark 2 and Spark 3 both, and that didn't pan out as we expected. So we focused on Spark 2, basically saying Spark 3 will continue in parallel, and once it is stable enough, we are gonna switch. And that pretty much worked out. To be honest, to give the data point, we went to production with Spark 2 for all the queries, and later in January we switched to Spark 3, and that caused less chaos than trying to do multiple things at one time. Yeah, a handful of queries failing could mean real correctness, reliability issues. I mean, this is one thing uh, we learned the hard way that, okay, you need to take a look at, and for every correctness issue you need to rule out, because a handful of queries failing, in our case it turned out to be real correctness issues. Overall correctness has to be P0. I mean, we can't reason about the changing a user changing queries or basically data set changing. For the simplest join, which is using a field which is projected using a custom UDF, which behaves differently in Velox versus Java. The results could be different depending upon what a column value is. So it has to be P0 unless you can control this in most cases, which is not possible. And shadow signals represent past characteristics of queries. So you may go to production with 100 queries, 1 or 2 may need to be reverted back because there are some things which behave differently, specifically when it comes to allocation of resources when contention is there. Okay, we have a deep dive later today scheduled at 4:10. Please join if you are interested and are running Presto-on-Spark stack. And thank you for all the contributors.